members of the Faculty of Applied Science who are going to share with you their amazing research into some of the ways engineers are making an impact in our world. This research is very often interdisciplinary, meaning people from different engineering disciplines or different faculties like science and medicine all work together. Many of your professors in university will be research faculty, meaning that they spend time in the classroom teaching you, as well as doing research like publishing journal papers and working to solve problems that we face in the world every day. They're taking what they learn in their research and applying it when they teach your class. So hopefully these very short introductions today to just some of the research happening in our faculty will give you better insight into the variety of topics a degree in engineering may allow you to explore. Engineering research and the application of this research is truly changing our world for the better. So with that, I'll invite our first research spotlight to the stage. And at the end, you'll be able to use the Q&A in the stage to ask some questions.
Thank you, Erin. My name is Madjid Mohseni, and I am a faculty member at the Department of Chemical and Biological Engineering at the University of British Columbia. My background is in chemical engineering, but a lot of work that I do these days are related to environmental engineering, meaning that trying to work towards sustainable development or support sustainable development and work towards improvement of our environment. I'm also the co-director of the environmental engineering program at UBC, meaning that the undergraduate program that provides learning opportunities to the students towards environmental engineering discipline. As part of my work, I do work a lot with many different faculties and different disciplines from within the engineering, including civil engineering, mechanical engineering, and materials engineering, but also outside engineering, areas such as chemistry, microbiology, and even social science as well. So what I would like to start with this presentation is around UN Sustainable Development Goals. As you know, the United Nations set 17 goals that supports development towards sustainability, and these include areas related to climate change, reducing hunger and poverty, and so on. But one particular area that I would like to highlight here is around clean water. Now, we know that our planet is primarily made of water. 2/3 of our planet is covered by water. And in fact, we have plenty of water. But the fact is that even the drinking water that is plenty in the planet, and we do have sufficient, but is not available to everybody, particularly to people in developing world. So, as you may know, as you may have heard, many people in the world are dying, particularly children in developing world, because of the lack of access to clean and proper sanitation. And that's why this is one of the key goals of the UN Sustainable Development. And majority of the challenges are in rural areas and developing communities. I do have a table here that shows the number of people that are not having access to clean drinking water is so significant. And this is only what they could anticipate or they could gather in terms of the information, but the actual number is a lot more. In fact, it's estimated that close to 2 billion people may not have access to safe drinking water. What about Canada? We are blessed, of course, as being a developed countries, and we have plenty of fresh water. But even within our country, there are close to 6 million people who live in small and rural areas, and their drinking water is potentially at risk. And you can see here the sign of a boil water advisory notice in front of the First Nations communities. You can see the map of Canada with some numbers that may not be so legible on this slide, but there are within each province, there are communities that are lacking safe drinking water. And you may have heard from the news, from the media, that our First Nations communities our indigenous people, are actually at disadvantage when it comes to clean drinking water. So where does this lead us or leave us? The fact is that many students and many people within UBC, and perhaps some other places for sure, are working towards addressing this issue. And I'm showing you two pictures here that evidence of what UBC research, particularly the contribution of the students in terms of bringing safe drinking water to First Nations communities. On the left, you see a spotlight on the media that says 2-decade-old boil water advisory ended by UBC technology that was developed here at UBC with the contribution from our students. And you can see students actually working at the community with the indigenous people really to bring that water or to install that water treatment system. And on the right, you see a group of First Nations students working with our own students in the lab, really to work towards evaluating a technology that would be appropriate for these communities as well. So there are solutions, and our students are contributing immensely towards developing those solutions and implementation of those solutions. Now, how we do this one is really through a curriculum that brings hands-on learning through laboratories and also design experiences. Now, at the undergrad level, our students engage in design and working with the communities and industries. They try to work actually towards ill-structured and socially and technically complex problems that are there. We know that a lot of challenges that are out there, whether it's climate change, whether it's water, whether it's clean air, all of those are multifaceted, meaning that they require participation of various stakeholders and from various disciplines. And our engineering students and graduates are fully capable of capitalizing on that and working together with various groups and various disciplines to bring those solutions to the marketplace and to the implementation stage. Now, I'm showing you a number of pictures that really these demonstrate and show groups of our students at the undergraduate level, with some at the graduate level, working with communities as part of their even undergraduate curriculum, going to the communities, working with the community members, gathering information, understanding the real scenarios and real situations, and then coming back in the lab and doing the research, and even taking that research to the field and eventually bringing that solutions to the market. This not only gives them a great learning experience and opportunities, but also brings them a lot of opportunities to actually work together as a team and experience that and become more marketable. Just showing you one example. This is a community I showed the sign earlier that was on boil water advisory for 14 years. And there was actually, in fact, no solutions that the government could think of. But our students first started as a team working with various stakeholders, tried to develop a concepts, and then went to the lab and tested these technologies or possible technologies and brought it to the field, did some field work. And with success of that, it went through the construction and full installation, which eventually brought that sign that was there for 14 years down. And the community celebrated that eventually. And with that celebration, our students themselves celebrated and were able to cherish that moment with the community and share that event and that opportunity. And that community that I mentioned is still maintaining their safe drinking water even after a few years that it has been installed through the work of these individuals. With that, I'll stop and take any questions that you might have for me.
Perfect. Thank you so much. So if you have any questions right now, please use the Q&A in the stage to ask any of your questions about this type of research that you might be interested in, about anything talked about today, and we will answer those questions. We have a few minutes. So Madjid, one question that I have for you is, you work with tons of students, you work with lots of great communities. What's kind of the most rewarding part about getting to be part of UBC Engineering and getting to do some of the research that you do?
Well, the first thing is really working with bright and motivated students. That keeps me going. And students are the ones that actually keep me wake up every day and go in my office, go my lab, and go my classrooms. They are the ones who are motivated. They are the ones who want to change the world, and rightly they are doing so by going to these communities, by going to industry to make a difference. But at the end of it, for all of us, me, our students, really, when we do a project and we succeed at the project, at the end of the day, when we sit down with the community and when they say thank you, I think that is the most rewarding part of it. When they say, okay, well, now we have clean drinking water. I do have many, many quotes from the community members, from the elders, from the simple residents, that they say, we are so happy that we finally can drink our water. And with that, it brings hope to their communities, bring possible prosperities and everything.
Awesome. One question came in, just if you could elaborate just a tiny bit more on how the system itself works.
Well, we work on various technologies, but this particular technologies that I showed in the slide, this one is what we call ion exchange technology. The simplest and closest analogy or similarity would be Brita filter. So Brita filter has some beads within it, and those have the capabilities to remove some contaminants. So here we are using certain types of beads that they can remove the color from the water, they can remove nasty organics or harmful organics from the water, and in fact improve not only the quality of the water with respect to chemicals, but also the quality of the water in terms of aesthetics. So the water is a lot more pleasing, both in terms of taste and color. So it's really what it does. It just captures these chemicals and the colors from the water as water passes through the filter bed. And the unique part of this particular one is that it can last for years without really needing to regenerate or replace the filter materials. That's why it's so perfect for rural settings that are far from urban areas.
Excellent. One more question came in. If you can talk about any sort of plans to implement more of these water treatment systems in more Indigenous communities, or what sort of that kind of broader picture will look like in the future?
Well, that's where building teams and graduates are gonna work. All these three ladies that you see in the pictures, they were students from UBC. They are now in industries. They are the ones that are the hope for futures. They train with the proper way to engage with communities, but also proper skills. We know that there is a technical challenge that going through the engineering curriculum provides, but also proper way of interacting with others and understanding the social and economical challenges that the communities are facing. So by understanding all of these implications as you go through the engineering curriculum, you're able to be much more equipped when you go to industry. So we no longer work in a status quo in a traditional way. Instead, we do have a more innovative way that involves interactions, engagement, and capturing the community's perspectives in order to solve the solutions. So that's one way. Another way is that, of course, we are working with more and more communities to be able to implement those solutions that we develop as part of our research.
Perfect. We've gotten some great questions. Very last question for you. There's one question about kind of approximately how many students do you get to work with? I don't even know if you know that number, because I know it's quite a few. And related to that is, if a student was interested in working with your lab in the future, what would be your recommended path for them to do so?
Well, I am from Chemical and Biological Engineering Department, and also, as I mentioned, I'm the co-director of Environmental Engineering Program. So these two programs provide opportunities for the students to go through that path for sure, easily, because I'm involved and a lot of my colleagues that work in that direction. But that doesn't mean that if someone from civil engineering or mechanical engineering interested cannot do that. In fact, they could participate as well. So a lot of the students that work in my lab are undergrads as part of their co-op or summer students, but also graduate students. So at either stage, students can participate and get involved in such initiatives. And there are many other great initiatives within UBC as well that are contributing to the society.
Awesome. Thank you so much for being here today, and thank you everyone for your questions so far. Thank you, Madjid. We really appreciate you sharing your research and all of the amazing work that you do. So thank you for joining. I'm now going to invite our next set. We have two research spotlights presenting together. So I'm going to invite them to the stage, and then they'll have time for a Q&A after they present as well. So thank you so much, Madjid.
Thank you.
All right, so we have our next research spotlights ready to go. So you are ready to start your presentation.
Hello, everyone. My name is Chadia, and I'm a PhD candidate at UBCO. And me and my friend Dikshita are going to present for you today. Yeah, I'll go first.
Yeah.
A little bit about myself. As I mentioned, I'm a graduate research assistant at UBCO. My education background is I got my bachelor and my master's in civil/structural engineering in University of Texas at San Antonio campus. And I'm part of a research group called ASSET under the supervision of Dr. Toba. And I'm also part of the CPCI Education Committee, and my research focuses on developing seismic guidelines for conventional construction precast shear walls. I'm sorry, I'll explain that later if this is a little too much for you guys, but go ahead, Dikshita.
All right.
Okay. I wanted to talk a little bit about myself. So I'm from a tiny country called Rwanda from East Africa. And I moved, as I mentioned, I moved to the state, but the first time I moved there was 17 as a junior in high school. I spent 2 years there, and then I moved to Texas for my undergrad and my master's. And then I moved back home where I worked for the industry. And a little over a year ago, I decided to do my PhD, so I came to UBC Okanagan. As I mentioned earlier, my research is on precast concrete shear walls. The difference between precast concrete and normal reinforced concrete is that the elements are casted or prepared in like precast plants, and then they are assembled on the sites. Some of these circles you see on here are called their connections. So once these elements are put on the site, they have to be connected somehow. So my focus is on how can we design these connections so when we have things like earthquakes, we don't have disasters like the pictures you're seeing on the left. So we're focusing on like studying the behavior, how to make these connections stronger or ductile to avoid such a type of disasters. And go ahead, Dikshita. So I'll talk a little bit about my motivation. Last year, when I was back home, we had an earthquake in this area called Rubavu, like the one you see on the with the red dot on the on the right. It's throwing me off because of the emissions. Anyways, I'm sorry about that. So this area is close to a country called Congo, and Congo has a lot of volcanic activities. And since we're close to Congo, Rwanda experiences a lot of shakes once one of those volcanoes erupts or anything like that. So last year we had some damages in this area. And since Rwanda is very, very small, it's like around 26,000 kilometers squared, where you see the green where you see another dot, that's where I'm from. We felt that those damages. So that was my motivation in learning, like coming here and learning how to do code changes. So the knowledge I'll get here also can be implemented when I go back home in helping Rwanda create its own construction code, which is one of the issues we have right now in my country, is that we don't have our own construction code. So we use a code from the UK, which is like 20 years old, and they've done their own research, and this is based on their own conditions, so which is pretty different from what we have. So that was my motivation to come here and learning how people are able to build their own construction code. I'll pass it to Dikshita now.
Thank you so much, Chadia. Hello, everyone. I am Dikshita, and about me, like I'm a PhD student here in UBCO at the School of Engineering, and I finished my bachelor's and master's back in India, and currently I'm working with Dr. Lisa Tober with the ACID group, and the overall kind of the theme that I'm focusing on right now is towards development of sustainable housing solutions for the northern and remote communities in Canada. And in the past, I've worked as a structural engineer, a little bit about an entrepreneurship, and also in the corporate sector as a business manager and as a teaching assistant. So my journey towards my PhD was kind of interesting, because as you can see, there's this whole map of India to the right, and I'm sorry the animations are not working out, but like I am basically from the northeastern part of India, where you can see I've marked this BE. That's where I finished my bachelor's, and then I moved down south to finish my MTech in structural engineering. Then after completion, I kind of moved to the west for a job, and further towards the northwest for another job. Then I again moved down south to the south of India, and then up again. Like after spending this couple of years in industry and entrepreneurial experiences, I moved up to the Himalayas, where I had finished another master's in material science and structural engineering. And in all these years, it was a pretty exciting to kind of learn and see through different parts of India how like the communities where how everything was spread out and the infrastructure was. And I love to travel a lot, so that I would naturally go out and expose myself into situations which kind of seemed difficult, because I wanted to see how the communities and everything kind of sustained in those critical climates. And also, I had a pretty interesting journey arriving to Canada, where I am currently here in the Okanagan. Like literally, I had to take like 6 flight connections to actually reach to Kelowna, and had a little bit of fun. Of course, it was COVID, so got to see the pyramids because there was this third country stop. Then again, it was like a good exposure to kind of see the different sides of the world. And as a structural engineer, it was also a good like learning to kind of try and expand my views. And in the past, I have worked with upgradation of beam column joints in a reinforced concrete structure. I have worked into developing antibacterial concrete, and I've also worked like with avalanches and debris flows. And all of these wide range of experiences have taught me that, whatever we are doing in our research is kind of always applicable in one way or the other. And having said that, these are kind of like some structures that I was having a view over the years. So as you can see, there's a part that I've presented of rural Assam, then, places in Vellore and the cities that I've lived in. And these are like very traditional houses. I mean, we always see like the big city side of things, but then in the backyard, like, when we see those kind of establishments, it is also a bit dangerous sometimes, because most of these establishments, like people are exposed to the like climate change and other vulnerable effects. So this was also one of these major motivation that I chose to do a PhD. And after reaching Canada, and I'm still trying to learn about the northern and remote communities and the housing needs, it kind of also motivated me to continue to contribute towards the sustainable development goals. And having said that, I'm working towards this housing needs. And if I can develop a framework, which I'm working on right now, to kind of see how to fit best as a structural engineer to build robust, resilient, sustainable, durable, and repairable structures, so that they can go on. Because at the advent of climate change, these communities, they are the most vulnerable ones that get exposed to all of these conditions and disasters. So working locally here in the British, in the Okanagan and British Columbia and some parts in Canada, if I can develop this successful framework and replicate it globally, I believe that's how I would love to contribute, or my research will contribute towards the sustainable development goals. And having said that, I'm still discovering, how to kind of either work with a new kind of infrastructure, or reform something that is already existing. And yeah, that would be a little bit about my research. And thank you so much. Over to the MC.
Perfect. Thank you so much for both of you for sharing your research and giving us the insight into what brought you to do this research and what's motivated you and kind of where you've gotten to so far. That's amazing to hear from. We have time for maybe one more question. So if you do have any questions about the research just presented, please use the Q&A in the chat to ask your question. One quick question I have for both of you is kind of, what are you most excited about in the near future in your research? Or is there anything that you're really looking forward to coming up?
I'll go ahead. I'm very excited. I'm planning to start my testing soon of those connections I mentioned that connect precast wall panels to the foundation or between each other. So it will be interesting to see the behavior, because this type of connection, no one has done this test ever. So I'll be the first, which is very exciting. And then we get to see how they behave. And from there, we can make those code changes and requirements, which is really cool.
Yeah, and for me, I think I'm very excited because I'm also kind of trying to bridge things together on deciding a sustainable material at this point. Either it's about a new material that's going to come up, or it's about using things that we have in a more sustainable way. And I will be running out a few experimental tests, which I'm very excited about, and also numerical simulations to get the data flowing. So yeah.
Awesome. Well, I think that's all the time we have for today, but thank you both so much for being here and sharing your presentation with us. We really appreciate it. It was really exciting getting to hear about some of this brand new research and new things happening, and I'm hoping to hear more about it in the future. So thank you so much for joining us.